Well, question number one, we have wave A, which is here. And the question is, it has a larger what than wave B? It goes farther above and farther below equilibrium. Therefore, it has a higher amplitude than B. Waves A and B have the same. If I look at this case, what I find is that from A goes 1, 2, 3, 4 units from crest to crest. So it has a wavelength of 4 units, and B has a wavelength of 1, 2, 3. They both have the same. In this case, what they have is the same wavelength, which we can represent with my favorite symbol, lambda. What else have we got here? Are waves A and B in phase or out of phase with each other? So are they in phase or out of phase? Well, let's see what we've got here. They are lining up crest to trough and trough to crest, which means that they are out of phase with each other. So let's write out. I'll just write out here. Let's try the next one. Would waves A and B produce constructive interference, or would they produce destructive interference? Well, because they are out of phase with each other, what we find is going to happen is this. Wave A wants to lift the water up 1, 2, 3 units. Let's just make them meters. Wants to lift it 3 meters, whereas B wants to drop it down 2 meters. And so they're working against each other. So when things are out of phase, we go what's called destructive interference. So the answer is destructive. Now, let's see, we are going to do this. We are going to draw the resultant waveform that forms by combining these. Alright, here we go. I like this part here. So what we're going to do is this. What we've got is, we'll start at equilibrium. I'm just going to put a dot here at equilibrium right there. Well, I want to put a bigger dot than that. There it is, okay? And what we've got is wave A wants to go 3 meters, B wants to go down 2. So the end result is 1, 2, 3 minus 1, 2 gives us a total of 1. So what happens is we go from here to here and then back down to equilibrium. Now we're going to drop down 1 and come up. And so what we're getting is this, which I'll explain once I'm done drawing. Okay. I've drawn better waves in my life, but here's basically what we've got. At all these points here, which I sometimes miss, we got 0 plus 0 gives us 0. But let's take, for instance, this one here. I've got positive 3 and I've got negative 2, which gives me positive 1. Here I've got positive 2 and negative 3, which gives me negative 1. Now let's see what our next question is. Did the wavelength of the resultant wave, how to compare? The wavelength, it turns out, did not change. The wavelength stayed the same. But now the amplitude did change. The amplitude of the resultant wave was definitely, if we look at this, the amplitude of the red wave that we have here is definitely smaller than either wave A or wave B. Wave B has a 2 meter amplitude, wave A has a 3 meter amplitude. The resultant wave only has a 1 meter amplitude. So the answer here then is going to be, it has a smaller amplitude.